Hey, what's up, Algebra 1? Catlin here with lesson 4 of your homework this week about linear models. We have this scatter plot of points where they have measured how many people are in a crowd and what the maximum level of decibels that they had made in that particular crowd. So this dot right here would be, 78,000 people, and they got up to 138, you know, decibels as their maximum noise level. We have several, and you seem to see that as the number of people increase, the potential for loudness increases. And so, what they've done is they've drawn a line of best fit here in blue, and they have calculated an equation that matches that line of best fit, and this is the equation that they come up with. So that kind of sums up what's happening in the situation. Now let's read the questions. The slope of the linear model is 1.5. What does this mean in terms of the maximum noise level and the number of people? Well, the slope is the rate of change. And so what it's doing is it's telling us, because slope is always, rise over run. It's always rise over run. And so in this case, our rise is representing our decibel level, and our run is representing our number of people in the thousands. So 1.5 being our slope means that 1.5 decibels changing positively per thousand people, per 1,000. It's a rate, it's a unit rate of change. And so what that represents is, what does this mean in terms of the maximum noise level? It means every thousand people will increase max decibel level by 1.5. That's all that means. Every time we go up another 1,000 people, we have the potential to raise the decibel level by another 1.5 decibels. A sports announcer comes on and says there's 65,000 fans in the stadium. Our job is to use our line of best fit to estimate how loud they could get. Well, if there was 65,000, I want to use a line drawing for this one. I'd go up and I would try to make my line as vertical as I could. Seems like it hits our line right about there. I'm going to say probably like a little over 120. I wouldn't say quite 121, but I would say slightly more than 120 maybe, or about 120 decibels would be our guess. And to explain my reasoning, our line of best fit seems to match the data really well, so it will estimate for us. We can say our line of fit matches data well and estimates this level. Okay. And then lastly, what does the y-intercept of the line give us? Well, the y-intercept would be like if this kept going down here, and it's going to keep going and going and going. Now, this is segmented, and this is not counting by fives. This is not zero. This would be 55. So this would continue on and on and on and on again. So what it's saying that if there weren't any people in the stadium, zero people in the stadium, then we would expect a decibel level of 22.7 is what that's saying. So it's saying that zero people have 22.7 decibels. Well, that doesn't really seem to make a whole lot of sense because none of our measurements came from anything near that size. So I would say that doesn't really make sense. And plus, if there's nobody in the stadium, then it should be silent, right? So you can kind of think of your own reasoning there, but zero people would have that many decibels is what our y intercept represents. Later, guys.